Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we're dealing with the chapter Motion in a Plane. This is the third chapter in the grade 11 syllabus for physics in CBSE. Let's look at our first question. A projectile is thrown with a velocity v, making angle theta with the vertical surface, and it gains maximum height h in the time for which the projectile remains in the air. You need to find the time period of this projectile. So, how do we solve this question? Here's a diagram to make things simpler. First of all, note that the angle theta is made with the vertical axis. So therefore, the angle which is made with the horizontal axis must be 90 minus theta. So therefore, the velocity v makes 90 minus theta angle with the horizontal axis. And it is with the horizontal axis angle that we must be calculating the time and the maximum height. So maximum height h is equal to u square sine square theta, which in this case is 90 minus theta, divided by 2g. And time period is equal to 2u sine theta, which in this case is 90 minus theta, divided by g. So the value of h will be u square cos square theta divided by 2g, and the value for time period will be equal to 2u cos theta divided by g. Let's consider this as equation 1 and this as equation 2. Now, in equation 2, t equals 2u cos theta divided by g. So therefore, we can write u cos theta divided by g as the time period divided by 2. Now we'll put this value in equation 1. So in equation 1, h is equal to u square cos square theta divided by 2g. We can write this as half times u cos theta by g. Now we have a u cos theta left. So in order to make it similar to t by 2, we'll be multiplying and dividing by g. So that'll be u cos theta by g times g. So this is the value for h. Now we substitute u cos theta by g with t by 2. So 1 by 2 times t by 2 times t by 2 times g. That is equal to t square g divided by 8. So now that we got the value for h, we will now convert this in terms of t. So now t square will be equal to 8h divided by g. We're taking the terms to the other side. And taking square root, you'll get t is equal to root of 8h by g. And this is the right answer. If you look at our options, you see that option D, root of 8h by g, is the right option. Option D. Now, let's look at our next question. A bomb is released from a horizontal flying airplane. The trajectory of the bomb is. Now, you have an object, and the airplane is suppose flying with a velocity ux, and you are releasing the bomb. So while releasing the bomb, the vertical velocity initially will be 0, but then the acceleration due to gravity, that is g, will start acting on it. So the effect of both ux and g will ensure that this bomb follows a parabolic trajectory because as the bomb moves forward, it is also moving down because of the effect of gravity. And this means that the velocity moves, the velocity of the vertical velocity changes with respect to time. So therefore you get a parabolic trajectory. So therefore option A, a parabola, is the right answer. Option B, a straight line, is incorrect because the plane is flying horizontally. So there is already a horizontal component. Option C, a circle, is incorrect because there is no centripetal force acting on the circle. The circle has only gravitational force acting on it, and it's not high enough in order to make gravitational force as a centripetal force. Option D, a hyperbola, is also incorrect. Hyperbolic paths are present when you have space missions that wants to escape Earth's gravity. So when a spaceship wants to escape the Earth's gravity, then it follows a kind of hyperbolic path. But yet again, this is only theory and there is no practical applications for it. So option A, a parabola, is the right option when considering the trajectory of a bomb released from a horizontal flying airplane. Next question. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of acceleration of the stone? And we have 4 options detailing the magnitude as well as the direction. So, in order to better understand this question, here's a diagram of the same. So as you can see, you have a horizontal circle. The velocity is constant in magnitude, if not in direction. And you have a string which is tied to the stone, so that makes it follow a circular path. So there is already the presence of a centripetal force, so there is always a centripetal acceleration. Radial acceleration is present. And since this is a constant speed, there is no tangential acceleration. Now, in order to solve this question, we will use the formula for acceleration. Centripetal acceleration, AR, will be equal to R omega squared. And now we will be using that formula. So AR equals R omega squared, which we can write down as R times 2 pi nu squared. Over here, the frequency is given as 22 revolutions in 44 seconds. So we'll be putting in that value. So AR will be equal to R times 2, 2 squared is 4, times pi squared times nu squared. That is the frequency squared. So AR will now be equal to the value of radius is 1, then you have 4, then you have pi squared, and the value of the frequency is 22 by 44, the whole square. 22 by 44 can be written down as 1 by 2. So you have 4 pi squared into 1 by 4. So therefore, the value of the radial acceleration is pi squared. Now this is centripetal acceleration. That means it runs along the center. So therefore, it runs along the radius towards the center. So option A, pi squared meters per second square, and direction along the radius towards the center is the right answer. Because A, we're calculating centripetal acceleration, and B, using the formula, we got the value of pi squared. In the other options, either the direction is incorrect or the value of the acceleration is incorrect. So option A is the right option. Now, let's look at this question. 2 projectiles are fired from the same point with the same speed at angles of projection 60 degrees and 30 degrees respectively. Which one of the following is true? Their maximum height will be the same, their range will be the same, their landing velocity will be the same, their time of flight will be same. Let's look at each of our options. Option C, their landing velocity will be same, is an incorrect option because there are very many factors that influence this landing velocity, so it cannot be the same most of the time. Now, let's look at option D, their time of flight will be the same. What is the formula for time of flight? T is equal to 2u sine theta by g. So if we're taking the two scenarios, it'll be 2u sine 60 divided by g. T2 will be equal to 2u sine 30 divided by g. So if you take the ratio, then you have sine 60 divided by sine 30. That is equal to root 3 by 2 divided by 1 by 2. So therefore, the ratio is root 3 raised to 1. Now, if the time of flight was same, then the ratio will be 1:1 because they're equal. Over here, they're not equal. So therefore, the ratio tells you that the time of flight for the two angles is different. So option D is incorrect. What about option A? Maximum height will be the same. So for that, let's use the formula h equals u square sine square theta divided by 2g. For h1, this will be equal to u square sine square 60 divided by 2g. For h2, it'll be equal to u square sine square 30 divided by 2g. So h1 divided by h2, again u square and 2g gets cancelled. So you have sine square 60 divided by sine square 30. This is equal to root 3 by 2 the whole square, that is 3 by 4, divided by 1 by 2 the whole square, which is 1 by 4. So therefore 3:1 is the ratio here. So therefore option A again gets incorrect because the ratio is not equal. If these two values were equal, then the ratio will be 1:1. So the only option remaining is option B, which is their range will be same. And the reason for that is that the range is same when two angles are complementary. And if you look at it, it's 60 and 30, so 60 plus 30 will give you 90 degrees. So therefore, these two angles are complementary. So whenever their two angles are complementary, then their range must be the same. So therefore, option B is the right option. And now we have our final question for this episode. A ball is thrown from a point with a speed v0 at an elevation angle of theta. From the same point and at the same instant, a person starts running with a constant speed v0 by 2 in order to catch the ball. Will the person be able to catch the ball? If yes, what should be the angle of projection, theta? So, suppose we have projectile motion. The initial velocity is v0 and the angle is theta, and the projectile goes in its projectile motion. Now, at this case, a person is running with the speed v0 by 2. Now, for motion in a plane, the horizontal component will be along the x-axis and the vertical component will be along the y-axis. And it's due to the variation in the vertical component that we get projectile motion. So, in order for this person to catch the ball, he needs to run at a speed that is equal to this horizontal component of velocity. So therefore, the condition is v0 cos theta must be equal to v0 by 2. You cancel v0, you get cos theta equals 1 by 2. 1 by 2 is the same thing as cos 60 degrees. So therefore, the value of theta is 60 degrees. So therefore, option C, yes and 60 degrees, is the right answer. Now, if you take 30 degrees, then you'll still get the same range, but the problem is the speed will be way less. So you have to run faster in order to get that ball. So therefore, for that person who can only run at v0 by 2, it will not be possible. So therefore, option B is incorrect. And since you can technically catch the ball if you run at the horizontal component of velocity, option A is incorrect. And in option D, the angle again is incorrect. So if the angle is not 60 degrees, then it either becomes too fast or too slow for the person to catch the ball. So therefore, option C, 60 degrees and yes, is the right answer. Now that concludes this episode of NEET Preparation. For more of our videos on this chapter, don't forget to click the link in the description down below. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.